Happy Thursday, 7th graders. Here's today's little instructional video. Sorry, I forgot to embed the webcam, so I'm waving, but you can't see me waving at you. But I guess that's the way it is. So today's lesson is sort of similar to what you did on Tuesday. Tuesday, you found the number of events for two different or compound events. Today, you're finding the probability of something within that. So it's similar in that when you want to find the number of outcomes, you just multiply the number of outcomes for one times the number of outcomes for the other. When you're talking about the probability of sort of compound events, like for example, you have these marbles in this coin. When you're talking about the probability of picking a purple marble and then flipping heads, it's actually the product of the two probabilities. Okay, so you've done product of independent events before, or simple events. So notice the marbles is 1, 2, 3, 4, 5, 6, 7, 8 marbles. The probability of picking a purple marble is 1, 2, 3, 4, 5, 6, 7. The probability of a purple marble is 7 out of 8. When you're flipping the coin, the probability of flipping heads is 1/2. The probability of doing both is the product of those two probabilities. 7 times 1 is 7. 8 times 2 is 16. The overall probability for those two events is 7/16, just a little bit less than 50%. Okay? And that's how you enter the fraction here with the slash. And lo and behold, I get that positive feedback telling me it's right. Okay, I'm just going to do a couple more and then leave you be. I don't think it's something we need to spend a lot of time looking at. So again, probability, let's get more appropriate number here. A purple marble and then spinning blue. Oh, I'm playing with colors. Look at that. So the purple marble, there are two purple marbles out of 1, 2, 3, 4, 5, 6, 7, 8, 9. 4, 5, 6, 7, 8, 9. So probability of a purple marble is 2 out of 9. The probability of spinning blue, 1, 2, 3, 4, 5, 6, 7. Looks like there's 8 pieces. Probability of getting blue is 3 out of 8. Now, because I'm dealing with fractions here, I know I can reduce. 3 goes in itself once. 3 goes into 9 3 times. 2 goes in itself once. 2 goes in 8 4 times. And I get 1 times 1 is 1. 3 times 4 is 12. The probability of getting a purple marble and spinning blue is 1 out of 12. Now, if I didn't reduce that, that would be 6 out of 72. I'm not sure how IXL is going to respond, so let's see if I didn't reduce. If I didn't reduce, I do 6 out of 72. Oh, and IXL accepts that answer. I really don't like the fact that IXL accepted that answer. I really wish they make you reduce. So it's lucky that you're not doing this. For me, on paper, I would make you reduce. IXL apparently is not as strict in that regard as I am. So let's jump ahead to some harder problems, or supposedly harder problems, all the way up to 75. Flipping heads on the first coin, tails on the second coin. Well, I don't know why this is a hard problem. Heads on the first coin is 1 out of 2. Tails on the second coin is 1 out of 2. That looks like a 1 out of 4 possibility. Okay, and you could actually see that if you actually did out a little sample space of all the possibilities. There's only one of the 4 in which you do tails first. Okay, I did that, probably didn't need to, but I went ahead and did it. So let me jump up maybe to a challenge problem. See if the challenge problem. No, that's the highest level. That's the highest level. This is so exciting. This is going to be another quick week for math. I mean, flipping heads and rolling a 3. Heads, 1 out of 2. Rolling a 3, 1 out of 6. That looks like a 1 out of 12 probability. No J there. And now 2 marble groups. Again, this should be straightforward. I don't want to take any more of your time. If you do have questions, don't hesitate. Take a screenshot of what you're working on. Email it to me. But otherwise, hopefully you'll be able to get through this pretty quickly. And have a good weekend, because if you've got all your work caught up, you don't need to do anything tomorrow except a little check-in. And then you got a 3-day weekend. Enjoy.
What are you doing?